Hi and welcome to Math with BK. In this video we'll be discussing the types of sets. Now here there is a whole bunch of a list. Don't be scared, I will describe each one of them, and believe me, you won't have to remember any one of them. It's quite easy. So what is mean by when I say that types of set? Now this is generally used to categorize sets. For example, we human, we say male, female, right? So those are like sets. So a male set and a female set, something like that. So let's go one by one and try to understand what are the different sets mean. The first is the null set. Now the set which contain no elements at all is called a null set. So this is represented by the bracket, or sometimes it is represented by 5. Okay, and if it contain only a single element, then it is called a singleton set. So if let's say the set contain only one element, that is called singleton set. Now from this it is very clear, null set, null means nothing, so basically a set with no elements. Singleton set, single means one, so basically a set with one element. And then we have finite set. Now a set in which the process of counting of element definitely comes to an end is called a finite set, right? So in a finite set you can count the number of items. So let's say 1, 2, 3, 4. So there are 4 items here. That's why this is a finite set. And similarly for infinite set, let's say I have the set of natural number 1, 2, 3, 4, and it's going on. This is an infinite set because you cannot count the number of elements. It will go on forever. So 5, 6, 7, 8, 9, 10, 11, 12 and so on. So this is an example of finite set where you can count. Infinite set means you cannot count the total number of elements. The next one is equal set. Two sets A and B are said to be equal set if every element of A is an element of B, and also every element of B is also an element of A. So let me explain what is going on. Let's say I have a set A and I have a set B. Now every element of A has to be an element of B, and also every element of B should be there in A. Then it is called equal set. Now let us understand what is equivalent set. So equivalent set have the same number of element but not exactly the same element. So one example could be, let's say I have 1 and 3 as one set and A and B as another set. Now both has 2 elements but they are not same. Then we can say this set is equivalent set. Now what is a universal set? So a set which contain all sets in a given context is called a universal set. So this is like the parent parent set. Generally it is represented by U. Now for instance, I'll try to explain you with figure. Let's say there are small objects, each forming small sets. Now the whole box is the parent set. So you can say that the box itself is the universal set under which all other sets reside. Okay, so now subset. From the term it is very clear that let's say you have 2 sets. For example, I have A and B. Now let A and B be 2 sets. If every element of A is an element of B, then A is called a subset, right? So what is happening here? Let's say I have A and I have B, which is a bigger set. Now if every element of A is inside of B, then A is a subset of B, right? Now for example, let's say I have 1 and 3 in A, and in B I have 1, 3 and 4. Now all element of A are present in B, right? So I have 1, I have 3, but 4 is extra in B. So A is a subset of B. I think you have understood the point. Now what is a proper subset? If A is a subset of B and A is not equal to B, then A is called a proper subset of B. So if we take this example itself, which we are working here, now A is a subset of B, totally correct, but A is not equal to B. That is also correct because B has a element 4. That is why A is a proper subset of B. Now, what is an improper subset? The null set phi is a subset of every set, and every set is a subset of itself. That is, let me just write it down for you. So if you take the element phi, which is the null element or the null set, it actually is a subset of A, or it is a subset of B also. Basically, null element is a subset of every set. And if we write this way, that A is a improper subset of A for every set A, then it is called improper subsets, right? So this is how improper subsets is defined. So you can think this way, that it is not actually a subset, but all the elements are there inside the other set, so it's called an improper subset. So now let's talk about the power set. So what is a power set? If S is any set, then the set of all subset of S is called the power set of S, and it is denoted by PS, right? Power set is denoted by P of S. Now power set is always non-empty. For example, let's say if A has n elements, right, then P of A will have 2 power n elements. You can easily calculate it. So let's say A is equal to 1, then P of A will be 2. So there will be 2 elements, that is 1 and the null element, that is 5, right? So this is how the sets are defined. So these are the different types of set which we generally study in our set theory in mathematics. I hope that you have understood something from this video. If you like my video, please do leave a like and do subscribe, then I'll get some motivation to create more. Thanks for watching and take care.